Welcome to Math Does Matter. I'm Carlo Purugganan and I will be teaching you today about solving exponential equations and inequalities. Our goal is to understand exponential equations and inequalities and know how to solve them. First, what are exponential equations and inequalities? For a brief definition, exponential equations and inequalities are just like normal equations and inequalities. The only difference is that exponential equations and inequalities use their variables as exponents. To solve exponential equations, we must use the property of equality in exponential functions. So if b or the base is a positive number except for 1, then b raised to x is equal to b raised to y if and only if x is equal to y. In other words, if the bases are the same, the exponents must also be the same. This also applies in exponential inequalities. If the bases in both sides are equal, then the inequality symbol will also apply in the exponents of both bases. For example, if 3 is less than 3 raised to 2x plus 1, then we can now equate the exponents of both bases into x is less than 2x plus 1. Now, let's try solving for exponential equations and inequalities. For equation number 1 is the exponential equation, and equation number 2 is the exponential inequalities. For equation number 1, 25 raised to 2 plus x is equal to 125 raised to 3 plus 2x. Equation number 2, 36 raised to 2 plus 4x is greater than or equal to 216 raised to 5 plus 2x. The first thing we have to do is to make the bases equal or similar. 25 can also be written as 5 raised to 2, and 125 can also be written as 5 raised to 3. The second step is to expand the exponents. So we will multiply 2 to the parenthesis 2 plus x and 3 to the parenthesis 3 plus 2x. So the equation will now result to 5 raised to 4 plus 2x is equal to 5 raised to 9 plus 6x. Now the equation that you can see here now is just the basic equation. We can now solve for the x. The first step is to isolate the variables. So we must subtract negative 6x to the right side and negative 6x to the left side, so it will result to 4 minus 4x is equal to 9. To isolate 4 from the left side, we must subtract 4 from both sides. Now, the result will be negative 4x is equal to 5. To isolate the variable from the coefficient negative 4, we must divide both sides by negative 4. So now the result will be x is equal to negative 5 over 4. To solve for the second equation, which is an exponential inequality, we must also make the bases equal. 36 can also be written as 6 raised to 2. And 216 can also be written as 6 raised to 3. Just like before, we will expand the exponents of both sides. So we will multiply 2 to the parenthesis of 2 plus 4x and 3 to the parenthesis of 5 plus 2x. So now the result will be 6 raised to 4 plus 8x is greater than or equal to 6 raised to 15 plus 10x. Because the bases are now equal, we can now apply the inequality symbol to the exponents of both sides. So now we can write 4 plus 8x is greater than or equal to 15 plus 10x. To isolate the variable, we must subtract negative 10x to both sides so that the result will be 4 minus 2x is greater than or equal to 15. We will also isolate 4 in the left side, so we will subtract negative 4 from both sides. So the result will now be negative 2x is greater than or equal to 11. To isolate the coefficient from the variable, we will divide both sides by negative 2. So the answer will now be x is less than or equal to negative 11 over 2. The inequality symbol change signs because we divided a negative number. Because in the rule of inequalities, when you divide or multiply a negative number, the sign must change. And that's the end. Thank you for listening.